Hello friends, welcome back to IARE YouTube channel. Myself, I am Madhavi Devi, and today we will discuss system calls topic in operating system, which is covered for BTech 4th semester under the regulation of UG 20. So in today's session, we will discuss the system calls concept. Under this concept, we will see what is system call and what is the need of system call in operating system and how this system call works in operating system and different types of the system calls and system programs. The another concept, system programs, and then we will see the difference between a system call and these system programs. So these are the contents we are going to cover in this session. So after this end of the session, so the student able to use the system calls for managing different processes, memory and file system in an operating system. Let us see the first, what is system call? System call is nothing but it acts as an interface between of software applications and a kernel. So in last sessions, we already come to know the operating system, and operating system it is act as an intermediate between computer hardware and user applications, right? So this system call will act as an interface between of software application. Another word, applications are nothing but processes which are executed in a memory and the kernel. So here, so if you observe that, so user applications, we have user applications, and if you see in last sessions the abstract view of the components of the computer, so their hardware is on the bottom of that hardware, and hardware will communicate with the user application with help of kernel. Operating system will be stored inside the kernel, right? So this system call will act as an interface between of this user application and kernel. So suppose user application is nothing but a processes. Processes are nothing but a program is in a execution, right? So system calls. This system call will be act as interface between user application and kernel. These system calls will provide the operating system services to the processes. So these system calls will provide services, whatever services provided by the operating system to the processes via API. API is nothing but application programming interface. Application programming interface. This, what do you mean by application programming interface? So this interface consists of many functions, and these functions will take some inputs as a parameters and give the results back to the user, right? So this application program interface consists of many functions which will perform some action and produces some results back to the user, required results back to the user. So there are three common APIs we will use in, because we already have seen different operating system services in last session, and we already know what are the different popular OSs we will use in operating system. So what are the popular OSs we will use it? Windows, Linux, Mac, Unix. These are the different popular operating system will be used. So there are the three most common APIs which will serve this system call services to the processes under Windows Win32 API, POSIX API for POSIX based systems. POSIX based system is nothing but Unix, Linux and all those stuff. And Java API for Java virtual machine. Because a process has to communicate with the kernel with the help of system calls only. So the system call is act as an interface between user applications or processes and the kernel. So when we require this kind of system calls, when actually process requires system calls, what are the situations a system calls we require? Suppose while we are doing programming in a file system, we require to create a file and delete a files, read a file, write from the files, and all these functionality has to be performed with the help of system call. With the help of system call. And while doing of new processes creation and managing these processes, also we require system calls. Without these system calls, we can't able to perform these functionalities. And network connections. So these connections also, to establish the connection, to remove the connection, all these actions has to be performed with help of system calls. With help of system calls. With the help of these system calls, we can able to send and receive the packets also. So because these are the different scenarios where we required all these system calls. And access to hardware devices such as printer, scanner, memory, and if any process wants to store or you want to use the memory or any other resources of a computer, then with the user can able to communicate with help of system call. So till now you understand what do you mean by system call and why we require or what are the scenarios we will apply these system calls. So we are seeing the example how actually the system calls will be available by the operating system to the user processor. Suppose if we have the requirement, a program to read a data from one file and copy these contents to another file. So this is a task or this is a problem. How actually? Because this activity will be performed in different operating system in different ways. Suppose if you are considering command prompt disk operating system, thus, so we will give it of the command copy source file and give it of destination file. So once actually this copy command is coming, then the operating system will provide certain system calls, and in that system calls, this sequence of the system calls will be generated indirectly by the operating system. So if it is, because we already have seen that different popular operating system, if graphical, I can say that graphical user interface operating system is, for example, Windows operating system. So under Windows operating system, you will get very interactive environment. So where user can, because all the commands will be visible and you can able to select the items, select the icons in a graphical user interface, and we will perform the actions. So suppose if this is an activity, then we require to perform this activity, first we have to check that whether two files are existing or not. What are the two files? The input file and output file, because without input file we can't able to copy the contents to another file. So for that, first it will acquire the input file. For that acquiring the input file name, if it is a graphical user interface, then it will prompt on the screen, accept the input. Suppose if it is a command prompt, we will give the commands on the command prompt place. So once actually input file is ready, accept the input. Once the input file is ready, then it will search for the output, because where we have to copy these contents. So to acquire that output file name, under graphical user interface kind of the operating system, it will prompt on the screen. So accept input, and once accept the input, then it will start opening that input file. So once the input file is open, so maybe there is a chance contents may not be available in input file. So maybe file may not be existing. So in that scenarios, the operating system has to perform a system call of abort. Suppose if the file is not existing. So when it is trying to open the input file, if the file is not existing, then it has to generate abort file. Okay, if it is existing, then it has to create the output file. So if, okay, file is existing, and either it can perform abort or it can do loop. So till that all the contents are copied from this source file to destination file, or input file to destination file. So this is until that read complete. Suppose if read is successfully happened, then it will close the output file. Otherwise, it will generate abort, or it will send the message on the screen is that copy file is not happened successfully. If it is successfully happened, it will terminate normally. So these are the different system calls will be generated by the operating system to perform this activity. But as a user, we no need to worry about of all these system calls. So these services will be provided by the operating system with help of system calls. How we will implement these system calls? How actually it is available for the programming languages. So we will come to know so many programming languages, C, C++, Java, so many programming languages. Each and every programming language is having of their own runtime system, support system, which inclusive of compilers. So all this runtime support environment which is available inside the programming language is having of this system called interface. So the system called interface will act as a link to the system call. When user is performing some action, user requires some resource to complete the action. So then the system call interface will generate appropriate system call request and send it to the operating system, right? So this system calls in operating system, each and every system call is having a their unique identification number. Every number will be associated with each and every system call. This interface will maintain this whenever user, suppose if you observe here, when a process is in execution, then the memory will be divided into two parts. So there are two categories. So user mode space or user space and kernel mode. Because operating system will be sit in this place. And this in user mode space or user space, this all user applications will be resided. Right? So whenever user applications or processes request for any resource to complete their execution, it will generate a request. That request is in the form of system call. And that system call will be executed in a kernel mode by the operating system, whether to make that system call is available to the user. This system call, if under system calls, we will see in the next types of different system calls. If that functionality, that resource is available, it will send the control back to the user by providing the requested resource to the user. Once the task is completed, then actually it will be. Here, this system call interface will maintain a table. This table consists of all the system calls. Based on the priority, this OS will be taking the particular system call and provide the service back to the user. So the another word, while a user is generating a system calls, it will generate the system call with the help of interrupts. So this system call interface invokes the intended system call in OS kernel, and once that system call is able to provide the service and returns the status of the system call and return values. Right? So here, as we have seen in the previous, so the user or caller or the process need not worry about of how the system call is implemented. What are the sequence of system calls is generated to perform that service. So simply he has to, because that system call will be served via API. So if the programmer or user or processes comes to know and obey the API, so it will understand what OS will do and as a result call. This details of the OS interface will be hidden from the programmer by an API, because API consists of many functions, right? Print function, write function, read function. So it has, because under this function we have all this set of the system calls to perform this action by the OS, right? So this is a graphical representation. What we have discussed, the system call, because the memory is divided into two categories, user mode, kernel mode. So once actually process is in under execution, then it will generate, if it requires any resource, if you consider it as a service. So if it generates, you open some function call or some system call, then that system call will be taken and submitted into the kernel mode. So who will do that? That system call interface will maintain all these system calls by the different processes and maintained into the system table with ID. Based on the priority, the operating system picks the system call and sends the result back to the appropriate process, right? Here the system call interface will keep it up that all system calls, and then the results will be give it back to the user application, right? This is a way. So the API, system call and OS relationship. What is here? The memory will be divided into two categories, user mode and kernel mode. So in user mode, the user or process will create or will generate a request for certain kind of resources. Suppose if you take an example of, I want to write an information into a file. So here write is a function call, system call. So once actually that system call will be work via a system call interface and send it to the kernel mode, and operating system will taken care that particular system call and give it service back to the user. Once actually the appropriate service is completed, then control will be written in the normal position. In standard C library, if you consider, it is a program. We are writing a program for different purposes, different applications. So if you observe here, the printf greetings, some printf command I am giving. So when printf, where the printf function it is available in the studio.h library, standard C library. So when actually printf function is there inside that studio standard library, then it will perform internally the right system call. Right? System call. This system call interface will take this printf and convert it into a corresponding system call, right? And then it will submit to the operating system in a kernel mode, right? So once actually based on the priority, then operating system will give service back to the user, back to the programmer, the required results, and then continue the next further execution. This is a way in C library example how the system call will be functioning, invoking. So while in the system call, the user may require to send some amount of information, right? So it's not simply a simple calls. It has to send some amount of information to the system call. So there are three general methods we will use it to pass these parameters to the OS. First is more parameters. These parameters will be passed inside the registers. And another method is that parameters will be, if you observe in the printf function, one parameter we have passed. That if you observe here, see, this is a parameter. This information we are pass it to the right? So that information we can just pass it to the, one method is registers, and another method is that parameter stored as a block, table, memory or address of block passed as a parameters inside the approach, inside the registers. So this approach actually it will be used in the Linux and Solaris kind of the operating system. And once actually these functions by the user programs are processed, passed and keep it into the stack, and this information popped by the operating system and will perform corresponding action, right? This is the way the system calls require maybe some parameter, some amount of information, right, will be passed. So this is a graphical representation. Parameters for call, if you observe in the C, very simple example. See, printf of greetings. Greetings is actually you are passing the information. In the place of greetings, I can pass some parameters also. That parameters load either it is a block or either it is an address. If you observe that call by value, call by parameters, call by reference, you may are passing of some addresses, right, of the variables. So that values will be stored inside either in the register, right? So that from that register, that amount of information will be considered by the system call and give it service back to the corresponding user. Let us see the next concept, the types of the system calls. So till now, we have seen what do you mean by system call, what is the need of system call, where we will use this system call, how these system calls will be implemented. Now, what are the different types of the system calls are there in operating system to perform these functions, right? So, the system calls will perform, there are different categories of the system calls are available inside the operating system. The first one is process control and file management and device management, information maintenance and communication. These are the 5 categories of the system calls are available inside the operating system. So under this process control, this operating system is responsible for processes management. So for the any process, we can create a process, terminate a process and load that process to the memory and execute that process into the memory. And we require the process attributes and IDs, set process attributes, wait for time, wait event, signal event, allocate and free the memory. Once the process is created, allocate the memory, and again once it is completed execution, we have to free the memory. So all these system calls will be managed by the OS under process control. So the next category of the system call is file management. And this file management system call is responsible for file management such as creating a file, delete a file, open a file, close a file, because these are different activities we will perform on the files. Open and display the information and close the file, read the file, write file and reposition a file, get and set attribute. All these system calls are available under file management category by the operating system. So the another one is device management. So because any process may require, suppose while a process is in execution, it may require some printer, it may require some scanner, it may require some resources, right? So request for a device, and once the request is fulfilled, it has to release the devices, and we can perform the read and write and reposition and device attributes, set device attributes, logically attach or attach the devices, and all these system calls will be performed under device management, right? So now the next category of the system call is information maintenance. So if you observe that information maintenance, so you may also have seen some folders you are creating, and you may want to see that at what time actually this folder is created. And I want to set the time, date, and get system data, set system data, get and set processes, file or device attribute. All these system calls will come under to the category of information maintenance. So the another category is communications. So process will require the communications between one process to another process, and if it is in distributed computing, the process will communicate with another process in another system, right? So through the communication link. For all these kind of functionalities, so these are the system calls will be available. So create, delete communication connection, send and receive messages, transfer the status information, attach and detach, remove remote devices, and all these system calls will be commanded to the communications category. So now we will see, till now we have seen that different types of the system calls available in operating system, and we will see these system calls how we are performing in popular OSs, Windows and Unix. How actually these types of the system calls we are performing. So under process control, because we already have seen that these are the different categories of the system calls, right? Under process control in Windows, we will use this system call is create process, because the process will raise a request of create process system call. And the same under Unix operating system will use fork. So exit process, wait for single object, and here under Unix, wait, right? For file manipulation, under file manipulation category, to create a file, create file system call, read file system call under Windows operating system. These are the system calls are available. Write file, close handle. Not only these system calls, many system calls are available. Many system calls are available to perform or to take some services by the operating system and complete your activity. So for the same system calls in Unix operating system, open, read, write, close. Under device manipulation, set console mode, read console, write console under Windows, and IOCTL, read, write. These are the system calls available under Unix. So under information maintenance, get current process ID, set timer, sleep, and get PID, alarm, sleep. These are the system calls are available under Unix. So for the communication, under Windows operating system, create pipe, create file mapping, map view of file. So under Unix, pipe, SHM get, mmap. So these are the system calls. Under protection, set file security, initialize security descriptor, and security, set security description group. The same commands are same system calls in Unix, chmod, umask, chown. So these are the system calls will be used to perform the protection under Unix operating system, right? So these are the different system calls are available under Windows and Unix system. So now let us see what do you mean by system programs. So there is a slight difference between of system call and system programs. So the system programs are, system call is nothing but it acts as an interface between of software applications and kernel. And these system programs will provide a convenient environment for program development. It will provide an environment for program development and execution, right? So to provide that environment, some of the system programs are available or provided by the operating system that are divided into the following categories: file manipulation, status information, file modification, programming language support, program loading and execution, communications, application programs. Usually, most users will use this terminology rather than the system calls terminology. So operating system also defined by system programs, not the actual system calls. System call, the operating system service will be provided with help of system call to the user. So the system programs are providing an environment, platform to execute, to develop. So for this, we require these categories of the system programs are available in operating system. Let us see one by one what are these. So under file management, we required the system programs of create, delete, copy, and many of the system programs which will generate and manipulate the files and directories. Status information is nothing but when actually that file is created, and somebody will ask the date, time, amount of available memory, disk space. So the number of users are using the particular operating system, and so many of the information about of the system, that status information. So when the system is logged in, and if any error is coming, the debug information, and all these activities will be available as a system programs under status information, right? So file modification, if I want to modify any file, so we have some notepad editor, text editors to create and modify files. Special commands to search the contents of the, if you observe that Windows, if you give it under the Windows icon, search field is there. So search the contents of files or perform the transformations of the text. So it will provide the programming language support. So it will give it of compilers, assemblers, debuggers, and interpreters. Sometimes it will be provided as a system programs. And also the program loading and execution. So the loaders, linkers, and debugging system for high level and machine level language. So communications, under communication, to send and receive the information to one computer to another computer, and browse the web pages and send an electronic emails. So log in remotely, transfer the files from one machine to another machine. This, to perform all these activities, the system programs are available in an operating system. So now let us see the comparison between of the system call and system program. System call is initially I am saying that it acts as an interface. System program, it provide an environment, right? It acts as a interface when the process interface between applications, software applications, and kernel. So it is providing an environment. So under request, it will take low level request of the user program, because user will perform the request to the OS, right? So that will be performed in low level request. So here under system programs, it will take high level request also, high level language. Simply like write, create, we just perform the system commands that high level request or requirement of the program. And here the programming language system calls will be written in usually either in C, C++, assembly level language codes also we will use it to use it in system calls. But here under system programs, only high level programming languages only we will use it. So the user view is, it will act as an interface between services of OS and user's request, and the user process provided by the OS. So here it defines the user interface. It will create an environment. That is most important. System programs will create an environment for convenient and create the applications. And action. So the user process request an OS service using a system call. Here It transforms the user request into set of system calls needed to fulfill the requirement. So it may be categorized into file manipulation, device manipulation, communication, process control, information maintenance, and protection. It will be categorized into file management, program loading, execution, programming language support, status information, file modification, and communication. These are the system program. This is the main difference between a system call and system program. So this is the references I have used. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.